Welcome to this video where you will be introduced to the fundamentals of BlazeLIMS. It will take about 10 minutes of your time. BlazeLIMS is a Laboratory Information Management System, or LIMS for short. Its purpose is to streamline and improve the effectiveness of laboratory operation by capturing, tracking, organizing, and managing operational data. Now, the main product of a laboratory, of course, is information, which is produced via an elaborate set of processes with rigorous operational rules using many resources. BlazeLIMS helps manage the laboratory for improved performance in many ways. First of all, manual processes are automated with associated labor savings, turnaround and throughput improvements, and error reduction. For example, the output from instruments can be automatically captured. Reports such as C of A's can be automatically produced, instrument logs automatically maintained, and much more. Operational rules are enforced, ensuring consistency and eliminating error. Data is integrated into one database, therefore eliminating redundancy and assuring traceability of all changes. The data is shareable across a wide variety of different users. Data integrity, that is, its accuracy, consistency, availability, and security, is enforced and assured. You can refer to the BlazeLIMS Lab Manager's Guide and User's Guide for detailed documentation, and you can contact the BlazeLIMS hotline for additional information. For best video quality, follow the instructions here. BlazeLIMS uses data tables to contain the information about things in the laboratory it tracks and manages. A table may be for configuration, to specify how lab data is to be processed, or a table may be for runtime, to capture the lab operations as they occur. For example, there's a BlazeLIMS table with a row or record for every sample. Information about how to process the sample, such as workflow rules, is defined by a corresponding row in a sample type configuration table. There is a table containing a row for each aliquot or subsample that is to be processed through a laboratory method, optionally using an instrument and taking advantage of batching for improved throughput. Information about how to process the aliquot, such as size, dilutions, QC requirements, and so on, is defined in a corresponding row in a method configuration table. There is a table containing a row for each test result value that is produced by the method. Information about how to process each value, for example rounding, units of measure, and so on, is defined in a corresponding row in a test type configuration table, possibly along with an equation defining how the result is to be calculated, or a domain constraining the results to predefined values. In addition, some methods produce multiple values for each result, which are stored in a replicates table and used to calculate the final result value. When doing BlazeLIMS configuration, configuration tables may be populated via configuration screens. For example, on the screen for defining test types, you can enter a name, a description, units of measure, and format codes for rounding. In addition, configuration tables may be populated by bulk loading from spreadsheets. It is best to start out using the screens until conventions and practices are established before possibly moving on to use the spreadsheets for bulk loading. There are videos which provide training for configuring BlazeLIMS, and you can refer to the BlazeLIMS Lab Manager's Guide or call the BlazeLIMS hotline. Operational tables may also be populated using screens. For example, the log sample screen is used to create one or more samples along with its associated aliquots and tests according to its predefined sample type. Operational tables may also be populated automatically from other systems such as ERP or order entry systems. Other videos provide training on operation, and you can refer to the BlazeLIMS User's Guide or call the BlazeLIMS hotline. To get a good start and achieve a usable and meaningful LIMS system, you should first of all understand and configure just 8 tables. Domains are optional and may be used to set constraints on a result value that are enforced by the LIMS. Equations are optional and may be used to calculate a result value based on other result values or chemistry-related parameters such as aliquot size. Methods are required and define a laboratory procedure used to produce a set of one or more result values from a sample. Sample types are required and define a specific kind of sample in terms of workflow and other rules to be applied when processing the sample. Sequence numbers are required and are used to define the format of an automatically generated unique identifier for samples, work requests, batches, and so forth. These identifiers usually contain an automatically incremented sequence number. System configuration is required to set up parameters that control operation of the system on a system-wide basis, including things like workflow, variable naming, and so on. Test types are required and define a specific kind of result value. Users are required and define every individual who uses the LIMS. Next, we will provide a more comprehensive picture of configurations organized by category. Comprehensive sample identification is critical to LIMS sample management. Some of the sample identification parameters have associated reference tables to be configured. In addition, these identifiers may be renamed to provide a more user-friendly terminology on all the screens and reports. An area is a general location where a set of samples originate or is the owner or originator of inventory materials. Client is an individual user of laboratory information, usually one who receives results and applies them. A customer is a business entity user of laboratory information. A customer site is a specific site for that customer. A lab group is a subdivision of the laboratory responsible for performing particular methods. One example might be a contract lab and an internal lab. Matrix is a category of sample associated with providing additional parameters to define it. A patient is a subject as a source for a sample. A product is a product being tested. A product code is usually a quality subcode but has other uses in the system. A project is a set of work associated with the laboratory testing that would involve one or more samples. A project protocol is a phase or segment of a project. A sampling point is a specific origin or location where a sample is collected. Next, we will summarize tables that define how the LIMS will process samples and tests as they are logged into the lab and their analyses run. A control loop is the definition of a control chart to be automatically run on a specific result measurement. It provides warnings of control limit violations. A domain is a set of constraints that are applied to the result value. An equation is used to calculate a result value. Limits are a set of specifications against which a result value is checked for violations. A log template is for sample logging with default properties and testing. A method is a laboratory procedure for determining specific properties of a sample. A sample type is a specific kind of sample used to distinguish workflow, specs, etc. A test group is a category of methods or tests that are to be run on a subsample of the sample. A test type is a specific kind of result. A work request spec is a template for logging work requests with default properties, samples to be tested, and testing to be performed. Units is a table used to constrain units of measure representations and to provide unit of measure conversion factors as needed in providing chemistry calculations. A number of laboratory resources are used in carrying out the laboratory testing processes, and it may be of value to track and manage these. Some of them require configuration in reference tables if the LIMS is to do that. A container type is a kind of container for materials such as samples, inventory, stability storage, and so forth. An instrument is a piece of equipment to be tracked for usage and maintenance. An instrument type is a kind of piece of equipment intended for a specific use. An item type is a kind of item that you can purchase or make and track in inventory. A lab standard type is a type of laboratory standard intended for a specific use. A material type is a kind of material to be tracked in inventory. A user is an individual user of the LIMS to be tracked in terms of usage, actions taken, and so forth. A vendor is a source of purchasing for an inventory item. There are also a number of miscellaneous tables that define the details of ancillary LIMS functions. There are autolog formats, schedules, and sources to provide automatic sample logging based on calendars or received information from other systems. A bar print defines a specific barcode label format for samples, containers, aliquots, instruments, users, and so on. A drop-down defines override contents for any drop-down list in the system. A distribution list provides a set of receivers for notifications created by the LIMS on special events. A holiday schedule defines holidays, working hours, accounting periods, charge rates, and so on in order to do background calculations of costing and scheduling. An isotope table defines a radioisotope. Lookup tables provide nomograph-style lookups for calculations. A message format provides a custom configured format for notifications in the system, usually sent via email. A report specification specifies how a specific report is to be run. A sequence number is an automatically assigned sequence number generated for samples, inventory items, and so forth. A standard comment is available for providing comments that have specific content in specific circumstances. The system configuration table defines system-wide properties and parameters to provide overall control of processing. There are upload formats, schedules, and sources to provide the input and automatic loading of result values. If you have a stability system, there are storage conditions, the conditions summarized in which various samples are stored for stability studies. A test list has a predefined set of tests to be run on a stability draw. A study is a template for a stability study that's going to be run on a particular lot of material. A protocol is a template for the various storage conditions that one is going to run for a study. A protocol schedule is a template for the study draw scheduling and testing for a particular protocol. There are a host of tables associated with capturing and managing the operation of the lab. And the primary ones are mentioned here. There are batches, QC batch aliquot, QC batch test, associated with tracking a set of aliquots through a particular method that are processed as a group, either through prep or measurement. An item is an item that you can purchase or make and track in inventory in terms of its components and usage. Lab standards, to be able to formulate and track standards as they are created and used. Lots, used for lot tracking and lot release. Runs, which is an arbitrary collection of tests to be processed as a unit. Samples, including samples, aliquots, tests, sample containers, and so forth. Instruments, including instruments, their calibrations, and other records associated with managing them, such as usage. Work requests, a collection of samples with associated testing to be processed as a unit. In systems that do use stability, there are studies. A stability study defines the storage and processing for a lot of material. A study might have protocols, storage conditions for that study, and each protocol might have a schedule for drawing and testing associated with the study.